Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, rotate by 90 degrees. So what the problem is saying is we'll be given a square matrix. Okay, the task is to rotate it by 90 degrees in clockwise direction without using any extra space. Okay, so what we want to do is we want to rotate the matrix given this matrix, right? This is the given matrix. We want to rotate this matrix in clockwise direction by 90 degrees. Okay. So if you look at this input matrix, right? If you look at this input matrix, now we want to, as the problem says, right? We want to rotate it into clockwise direction by 90 degrees. So what we want to do exactly? So if you see, here is the input and here is the output. Okay. So here, if you look closely, the first row is becoming the rightmost column, right? The second row is becoming the second last column and the third row is becoming the first column, right? So this is what we want to achieve, right? This is what we want to achieve. Now, how can we achieve this, right? How can we achieve this? Now, today, due to the time constraint, I'm not going to explain the naive approach. Okay. So I am going to explain whatever is expected. That is time complexity. The expected time complexity is O of n square and space complexity is O of 1. Okay. That is no extra space you want to take. Okay. Okay. Now, now, how can we solve this problem? Okay, how can we solve this problem? So so I'll make it very easy for you to understand. Okay, I'll make it very, but just one request to subscribe to the channel, like the video, comment on the video, because at the end of the day, the subscriptions motivates me to create videos for you. Okay, thank you so much. So let's quickly see. Okay, so what we can do is we'll use two steps to solve this problem. Okay, Step number one will be to transpose the matrix. Okay, to transpose the matrix. Okay, now what is transpose matrix? Okay, what is transpose of matrix? So the element at a given cell, for example, at ij, right? The element at ij, okay, goes to the element at ji. As simple as to understand, right? Okay, the element at cell ij goes to the element at ji. Okay, so for example, if this was a matrix, right? If this was a matrix 1, 2, 3, 4, 5, 6, okay, the matrix will become something like this 1, 2, 3, 4, 5, 6. Okay, so the element at ij, for example, this particular case we understand, right? The element at this goes to, for example, 0 to 0, 1, right? 0, 1. The element at 0, 1 is going to 1, 0, is going to 1, 0. So 0, 1. So this current position is 0, 1, and it is going to 1, 0. If you see 1, 0, row number 1 and 0 column. Okay, so transpose of a matrix says that the element at ij goes to the element at ji. Okay, now the use cases of transpose matrix is like it is used in matrix multiplication, inner product, and all those applications. Okay, so simple thing is to transpose a matrix. For example, now let's consider our input, right? Let's consider this input. So what will be the transpose of this matrix, right? So let's also write the pseudo code. So the pseudo code will be I equal to 0 to n. Okay, and there will be two for loops, j equal to I to n. Okay, j equal to I to n. Okay, so these will be the two for loops. Okay, and what we want to do is we want to swap ij, ji. Okay, to make it simple, I won't write much code here. We want to swap the element at ij with ji. Okay, so here, for example, now if we consider here, right, what it is going to be. So for example, I is 0, right? I is 0 and j is also 0 here, right? I is 0 and j is 0. So ij, and the one will go, one will be as it is, right? One will be as it is. Now if we come at this particular, right, j will be incremented to 1, j is equal to 1, since it is an inner for loop, right? So this 2 will be swapped with this one. Okay, this 2 will be swapped with this one. So here 4 will come, here 2 will come. Okay, then this particular 3 will be swapped with this particular 7. You can have a look, you can dry run this code. Okay, so this is going to be what? 7, 1, 2, 1, 4, 7, and here 3 will come. Okay, here 3 will come. Okay, now we are done with the first iteration of this j for loop of the inner for loop. Now we'll again go to this outer for loop. Now I is going to be 1. I is going to be 1 here, and so will be j. J starts with j equal to I, right? J equal to I. So j will be starting from here. Okay. Now this particular we'll start with this particular element. So this will be as is I, J, and Ji because both are same. I and J both are 1, 1, right? 1, 1. So it will be as is. Here, the element, this and this will be swapped. This and this will be swapped. Okay. So here 8 will come and 6 will come. 8 will come and 6 will come. And finally, so we are done with the second iteration. Now again, this outer forward will come into picture. I will be 2. Okay, J also will be 2, right? J also will be 2. So only this particular element we are left with. Okay, so this will be as is. After swap, this will be as is. Okay, so step 1 gives us the transpose of the matrix, and this is the current state. Okay, this is the current state. After step 1, this is the current, this is the state of the matrix. Okay, this is the state of the matrix. Now, step 2. Step 2 is simple. Just reverse the elements in each row. Just reverse the elements in each row. Okay. So if you see, so what we are going to do here? So this, so just reverse what will happen. For example, we'll start with each row, right? So it will be 7, 4, 1, right? 7, 4, 1. Reverse each row. Reverse elements at every row. Okay. So here it will be 8, 5, and 2, right? And 9, 6, 3. 9, 6, 3, right? 9, 6, 3. So if you see, so this is the step number 2, reverse the elements. Okay, reverse the elements at every row. So that's what we have done here. If you see here, so 147 became 741, 258 became 852, 963 became, sorry, 369 became 963. Okay, and with these two steps you have achieved the clockwise direction, the rotation in the clockwise direction. If you see here, right? If you see here, now how can I show you, right? If I just zoom out, right? So if you see, so this is the expected output. So this is the expected output, right? 741, 852, 963. So in two steps, we have achieved the clockwise rotation by 90 degrees. Okay. Okay. So I hope you have got the intuition. Now, pseudocode. Okay. So let's go to the code. I think you'll understand better. Okay. So before going to the code, I'll request you to subscribe to my channel, like the video, comment on the video. Okay. So let's quickly write the code. So this matrix will be what? Generally, it is going to be n by n. So int, let's write int n equal to matrix dot length. We'll say, okay. Now what are we going to do? The first step, the step number 1, to transpose a matrix. So transpose the matrix I less than n plus plus I. And as I've already written the pseudocode, j will start with I. J less than n plus plus j, right? And simply what we want to do, we want to now swap the elements. The element at ij goes to element at ji, right? In temp equal to matrix of I, j, matrix of ij. Now we'll assign matrix of ji, right? Ji. And matrix of ji will assign temp to the matrix of j. That is, we are swapping ij with ji. Okay. So this is done. Step 1 is done to transpose the matrix. Now step 2, we will reverse int I equal to 0, I less than n plus plus I. We will reverse the elements at every row. And the for loop will be j equal to 0. J will go till n by 2. I'll explain this plus plus j. Okay. Now I'll just explain this logic. In temp equal to matrix of I, j, right? And matrix of ij will assign matrix of I n minus j minus 1. Okay, I'll explain this and let's copy this thing. Yn minus j minus 1. Okay, equal to 10. Okay, equal to 10. Okay, now, yeah, so this is step number 2. This is reversing the elements at every row. Okay, so with these two steps, it will solve a problem. Now, let's quickly understand this particular logic, right? Let's quickly understand this particular logic. Let me copy this. Let me take this snippet out. Okay. And let me, I think, copy here, right? Copy here. Yeah. Or, yeah. Let me copy this snippet here. Okay. So here, Sorry, this is j equal to 0. Okay, j equal to 0, not 9. This is j equal to 0. Okay, this is j equal to 0. Okay, so what we are doing here is the outer loop will be I less than n, and the inner loop will be j less than, I mean, we'll go till half of n, right? Half of n. So what is happening here exactly? Let's see. Okay, so for example, j is here, right? And I is here, right? J is here and I is here. So here, 1, what we are saying is, so we took, for example, we took matrix of ij into this temp variable. Okay, and then what we are saying here is this particular position. Okay, matrix of that is this matrix of ij equal to matrix of I n minus j minus 1. So what, so n minus j minus 1 will give us what? So n is what? 2. N is not 2, n is 3, right? N is 3 minus j is what? 0. Okay, minus 1. N minus j minus 1 will give us 2. So, this particular matrix of I, n minus j minus 1 will give us this particular position. So what we are saying is, we'll copy this one into this one. 7, 4, and 1. We are swapping like this. So what we are doing here is, we'll going till this. Okay, we are iterating j till here, and we are swapping like this. Okay, we are swapping like this, right? So n minus j minus 1 will give us this particular element. For example, if this was the case, 1, 2, 3, 7, and 9. Okay, so what, j will go till here, and what we're going to do is, we will iterate. N minus j minus 1 will give us this. Okay, we'll swap this. Okay, and the next j will swap this with this one. Okay, with this one. So this particular part takes the second half, takes the elements from the second half. Okay, takes the element from the second half. Okay, and that is why we need not go till j less than n. Okay, we n by 2 is sufficient. This will take care of the second elements at the second half. Okay, so this is the intuition. Okay, this is a code. Okay, let me compile this. Let's quickly see. Yes, so the output is matching. Let's submit. I'll also show the C++ code. Okay. So if you see, the test cases are processed, and if you see, we are taking time complexity is O of n square, and space complexity, we are not taking any extra space. Okay. Okay. So this is what was the expectation. Okay. Let's quickly see the C++ code. I mean, not much difference here. Okay. So here what we are doing is transpose again. I have not explained this, and we have swap internal function of C++ and then reversing, right? This we are doing the same thing, what I've explained. I'll also attach the code in the comment section. Okay. Thanks for watching. Have a happy, healthy, and a great day. And also please do not forget to subscribe to my channel. Thank you so much.